Hi, in this video we're going to talk about Microsoft Project Conversation Learner. So I was writing an article about the product. It was finally announced at Microsoft Build Conference in early May. I'm pretty excited to be able to finally talk about it publicly here. I was going to have this big article and I realized some of this stuff is better explained in a video, so I'm going to try to walk through the article and then also give a quick demo in order to help people understand. So yeah, this article will be published shortly. So it is a cognitive service lab. Microsoft has many cognitive services. The ones that are not labs are generally available. They have service level agreements and a bunch of higher performance. So we're mainly looking for a bunch of feedback for early adopter customers. You'll notice it has the project prefix. You can look at our docs over here as experimental tag, and this is kind of saying it's not intended for production or market ready stuff, but people who are really interested in this, we'd love for you to try it out and give us feedback. And so yeah, the purpose of this article was to bring awareness of the project and then also at least provide a little bit more context, understanding about what Conversation Learner is and what it tries to solve, so we can get more people using it and get better feedback from them. And in order to understand it, I'm going to break this video down into kind of three sections that align with the article, which is, what is the product, why should you use it, and then some details about how it works. So one thing to note is, I guess there's, at least from my experience, there's people on all different areas of the spectrum of bot development. Some people are, it's kind of this hot new thing. They're just entering the market. They don't have a lot of experience with all the different toolings, technologies out there, may not even know what it means to build a bot. And there's other people who have been building bots for a while, and they're basically hitting the limits of the current state-of-the-art technology, and they might also be interested in this. So I'm going to try to cover all the spectrum, bring all the new people up to speed, and then also in the how it works part probably will be valuable for the more experienced people. Okay, so what is it? First, in order to understand what Conversation Learner is, we're going to take a step back and make sure you understand how current bots work and how they are extended and over time, at least under the Microsoft stack. I don't have too much experience with other stuff. So we're going to look at this chart here and actually have maybe a better diagram in this PowerPoint here. So let's start this up. So we're going to start with the most basic of bots, and at least the vocabulary Microsoft is using here is you have these things on the far left are called input channels. So we have Cortana, Teams, and Slack, if you can see my mouse cursor here. And those all have their own representation of what the user typed, all the members of the current channel, and they send that data to some service. And because they're all different, but you don't want to write your bot to handle all those different communication, Microsoft provides a thing called Azure Bot Service, which normalizes all those different channel protocols into a single one that your bot can understand, sends it to your bot, which is just a web app. It's nothing fancy. It just has a special endpoint that's well known, and there's a standard, you can think of like a protocol for messages that come in, and then they're all uniquely identified, so they come in, get processed, get sent back out to the proper channel, and you can obviously have multiple users talking and all that nice stuff. And so for the empty external services column on the right is empty for now because we're assuming our bot is the most basic of possible. The entire bot logic is just coded right into it, and there's a single endpoint that it's listening to, which is API/messages. So this could be a C# web app, ASP.NET Core, Node, pretty much anything, Go, Python, anything you want, as long as it understands the protocol. Now it just so happens that if you use some of the frameworks that we give you, then it makes this stuff pretty easy. So Microsoft has this repo over here called botbuilder.js, which is kind of the main starting point here, and they give you all this framework that kind of works into well-known stuff like ASP.NET Core or Express and RESTify servers for Node if you prefer those technologies. All right, so now let's kind of walk through the example message here. Okay, so I've already explained the channels. You can obviously imagine your bot can respond not only with text but different cards. Pointed the repo out here, And now we're going to take a look at what happens. Say you've written this text bot, and you find obviously there's many different ways to say things in English. This is not something you want to have to program, so you're going to go off to some custom language understanding service and do some NLP work for that. And of course, Microsoft has a service for there, and of course there's many others. Amazon, Google, they all have their own similar ones. But the one from Microsoft happens to be called previously called Lewis. Now I think it's just language understanding in Azure. So that receives the message first. You can parse the intent of the user, which is, if we take kind of the canonical example of the Lewis website on their homepage here. If this loads up. So this example on the right, if you zoom in here, it says 2 tickets from Cairo to Seattle. And the intent right here is I want to book a flight, and it recognized that the source city was Cairo and the destination was Seattle, and even picked up the number 2. So it has essentially all the information it needs for that bot to go get that booking for you. And this, I just chose it as a simple one because it's the first one on the Lewis page, and it's pretty easily understood about booking flights. That's the bot that we'll use, and we're going to build one that's a basic text bot, and then we're going to look at how that bot will work in Lewis, and then we're going to also look at how that works in Conversational Learner, and then we're going to even try to build that bot from scratch in Conversational Learner. And it should be a demonstration of just how fast you can do stuff now. Okay, let's go back to PowerPoint here. So here we're just demonstrating that, yeah, your bot can add on external services to kind of extend its ability, but you still have these 4 major components, which is input channels, Azure servers, bot, web app, and external services. Okay, so the point, this is a little subtle here because I haven't highlighted the box, but you notice when I go back and forth between these 2 slides, remember this section is on what is Conversational Learner, and I previously was explaining what is a bot. And we're currently looking at a bot with the Lewis service, and all we're going to do to get it to work for Conversational Learners is essentially swapping that out to, instead of using Lewis, we're going to use the newer cognitive service called Conversational Learner. And remember, it's preview, it's lab, it's not official yet. But yeah, it's that simple. It should behave very, very similar to the code, and we'll certainly take a look at that in a minute. But essentially, you can think of it as, again, it's another external service your bot calls. And yeah, so now we have the question of, okay, that's great. We had Teams and Slack and Cortana or whatever hooked up to our bot talking to it. But let's take a step back and look at what it's like to develop. So in order for your bot to respond to Teams and Slack, it has to be published and going through all that protocol normalization. But when you're just doing development, you're not going to deal with all that. So of course they've built this special bot emulator program that is free. It comes with the bot framework, and you would download that and run that on your machine to not have to worry about publishing. You can test everything local. So what that does is it automatically outputs messages in that standard protocol instead of having to go up through the service. So that's why I've positioned the box kind of in the middle of those 2 columns, because it performs a function of both of them. And the rest of the bot logic stays the same. And the point we're making in this slide is that, Conversational Learner is almost very similar. It has its own UI. It's not the bot framework emulator, or you can use the emulator, though we have our own UI that offers a lot of extra features I'll explain later. And yeah, it just sends messages to the bot, similar to the other one. So you can see the points over here. Install with Node, just like all the other packages. You're not only using the UI to test the bot, just like the emulator, but you're also using it to train your models and build a bot. So the UI has become kind of purpose-built for this, which is really, really fascinating. And so the key takeaway from the what is it is, bot development consists of these 4 parts. You have input channels. You got something to normalize all the different types of channels into a standard guest protocol. You got your bot, which is just a website that has a server that understands a well-known endpoint, and the standard for Microsoft stuff is API/messages. And then you have external services that your bot calls to kind of enhance its behavior. So things like language understanding, Azure Search. You may have your company query a database. You can imagine customers shopping on your bots or ordering food or any number of things. And then I guess the biggest one that I wanted to drive here is that development with Conversation Learner should feel very similar. We don't want to disrupt your workflow too much, even though we're introducing a ton of new concepts. It should feel right at home. You install it with npm. It's got the same syntax and recognizer formats, and you can think of it as an external service that your bot calls to make decisions. Okay, so I ended up not finishing this PowerPoint, so we'll go back to the article to walk through kind of the next stuff. So already touched on this stuff. So now we're at the next section, which is, why should I use it now that I know what it is? So we're going to take a look at some of the problems. There's many, but here's, I guess, the 4 that I've at least identified as being pretty helpful. Is the first one is, I think, the developer feedback loop is a current problem in the existing technology. So to implement a change in your bot, usually you have to update multiple different components. So for example, you would update, say, your language recognition service to output a new intent or detect new entities, and then you have to go update your code in your bot to take a handle or to recognize that new intent, handle that output, and construct some new message that composes those entities into a phrase and responds it, right? So there's 2 different parts you have to synchronize there. There's a deployment that has to happen when you change code. The next, probably the bigger one, which is kind of the reason Conversation Learner exists, is the learning aspect of it is the machine learning. So once you try to program around all these different things, your code ends up being, a ton of edge cases and brittle nature based on the current state of the bot and what is known, what context is the user in. And so really, if you break down the name Conversation Learner, it's pretty self-explanatory, right? It's not only understanding a single input, like Lewis, it's understanding the entire conversation. So it has way more context to predict the next action. And then also the learner part is the machine learning, which is it's learning the whole conversation. So that's kind of the little interpretation of the name there. And what this does is it means is you can take a lot of the code that you were writing, and that'll be basically absorbed into the machine learning model. And there's an accompanying video that's already on the docs that we have, this video here. But one of the key phrases that we've been telling people is this, code what's correct to code and learn what's easy to learn. And I think the example they used there was, you're not going to try to learn authentication or inventory or certain hard business rules, right? You want to leave the learning over to the nuances between predicting actions and variables of state, right? So stuff like that. So I briefly mentioned before, but it requires developers and code to make changes to the design. So, say we have our example of, go back here and say you want to, 2 tickets from Cairo to Seattle. And then, you have your product owner come and say, oh, you know what, we need to handle this scenario as well. Well, they usually have to go get a developer to write that code, get someone who's familiar with Lewis to go update the new intent and do all that stuff. But it would be really nice if the person who understands the business domain can just go make that change and have very high confidence that it is working correctly. And so we'll see how that works. And this is, I guess, not to be understated. We're kind of imagining this is opening a whole new class of bot development right now. And you imagine if you're a company, you don't have the resources to hire all these developers and stuff like that. We're kind of imagining, the same way you have what you would call higher level information, like UX design. We want bot designers. We want people in that sort of tier where they don't have to worry about all the code. They know the customer really well. They know the problem domain really well, and they can create a very sophisticated bot just by using our interface. So there's many different people trying to solve this, or companies trying to solve this, and ours is also handling this. So the next big pain point here is, obviously every time you have to change code, you have to deploy that code, and that actually introduces, risk for every time you deploy. And in some cases, you can say, okay, well, maybe it's actually good. You can guarantee that nothing changes unless you deploy. But I would say, for the most part, say no one's going to write the bot perfectly the first time. There's always some customer input that you haven't seen that can be easily resolved by a human, but you just didn't account for it, and you're going to have to make that update. And it would be really nice if you could just click a few buttons and update that, and you'll guarantee that you haven't broken anything. So that's all these problems. We'll look at how conversational learner solves them. So developer feedback loop, code complexity as your bot scales to cover more inputs and exceptions. The current technologies usually require developers to code and make changes to bot design, and then it's that itself becomes a barrier to deploy the bot and make changes. So now let's look at how conversational learner solves each of those. So in particular, they're kind of perspectively aligned here. For the developer feedback loop, we have a reactive thought process. So if you look at a current, state of the art, I guess would be Lewis for Microsoft. Maybe there's other stuff out there. You usually have to go into Lewis, assume you know what your bot's going to do, program the intents, the entities, all that stuff, get that working in their UI, and then go back out and code, and then finally go test your bot. So you're actually preemptively assuming you know how your bot's going to work before you actually use it. That works, but it's actually not the most intuitive way. It'd be really nice if you could just type into the web chat emulator what you want your bot to do, and then type in what you want to respond, and anytime it's incorrect, you just correct it. And so that's how we work in conversational learner. So you don't have to anticipate anything, which means anyone can do it. So, okay, here's that phrase: code what's easy to code and learn what's easy to learn. This is the part that helps reduce that scaling issue with the code complexity. So let's see, the next one is you can update how the bot responds to user without redeploying code. And the reason you can do that is because a lot of the decisions your bot was making was stored in our external service. So you can obviously update that part without redeploying your actual bot code. And I briefly mentioned on this one, it's pretty substantial, but it enables non-developers to develop a bot, which is very exciting. We have, example of a customer support agent who, deals with customers. Now, perhaps they can actually go suggest a fix or actually update the bot without having to, go up the whole chain of command and get that implemented by a developer. Okay. So in summary, this is a new way to build bots and train models on a task-based conversation, and it solves, some of the major problems with existing bot development. And I'm sure some of you have been feeling the pain from some of the problems above. So in the next section, we're going to take a look at how it works. And in order to do this, this is the part where I'm going to actually show you the three different bots, the three different implementations, because I think it really makes a lot of sense. And then I'll reference back those points I made earlier. Okay, so the first, most basic one is this static bot. So let's jump over to VS Code here. So let's get this cleaned up. So I have a branch here called text, which implies it's the simple text matching or static bot. All the logic's coded in here. There's no external Lewis. There's no conversational learner. This is about as simple as you can get. And remember, we're trying to recreate this 2 tickets from Cairo to Seattle. And we're going to see how this is done with simple text. So first, let's take a look at the project. This is just standard, Node server. We're using Express. We have the Bot Builder SDK and a couple other packages that help us do running the server and watching and stuff. And we're coding in TypeScript here. So the kind of entry point is the Express server. So you can see how simple this is. You just create a bot framework adapter. If you have actually registered this, you'll get an app ID and a password, and that's how you can go add your bot to like Teams or Slack, whatever, by putting it up there in registry. And yeah, you start the server, you listen to that special endpoint that is kind of well known as the place where messages will come, and it's API/messages, and then you take the current request and have the adapter process it for you. And now this last function is actually the bot. So you can think that the bot is basically just a function that returns these new activities to return. And then we're just going to start the bot on this default port. And yeah, that's pretty much it. So actually, I want to do this in debug mode so you guys can really understand what's going on there. So I'm going to go ahead and press F5, and we will go into the bot. It's at debug point. Okay, so yeah, so I kind of stopped short here. So this was the server. Yes, this was the entry point. This was just showing you all the server stuff, which is the Express specific thing, and we reduced our bot down to a single function, or whatever, that just takes in turn context and then calls send activity whenever it needs to respond. And then I have this separate file called intent, which just tries to extract all of the logic about and recognizing intent from the text. And I tried to model it similar to how Lewis will behave, so you can see how easy it is to swap this stuff in and out. Okay, so let's take in that phrase, 2 tickets from Cairo to Seattle. Okay, so we hit our breakpoint here. You can see the text is 2 tickets from Cairo to Seattle. We're going to go into our recognize function. Remember, this is all just handwritten. This is the thing you do not want to do, but I have to show you the problem in order for you to understand the solution. So this is why we're walking through this. So you see this is kind of, if you're brand new to bots, it might be a rather easy approach for some cases. Just do regular expression matching. I'm looking for the word book or flight, and if it has that, I'm just going to assume that that's what the user wants to do. It's pretty naive, but let's say it works for now. Yeah, and we walk through, and then we also make assumptions here. I jumped the breakpoint over, but we were looking for the word after the word to and the word after the word from to detect the source and destination city. And then, yeah, I don't believe I have an entity for the number of tickets here, but okay. So now we've recognized the intent, and this one actually did not have the word book or flight, so it skipped it. So we'll have to fix that later. But for now, let's just enter a new one. I think I intended to actually type this. Okay. So, yeah, let's make sure we get into this line. Cool. So, it's, wow, way into the TypeScript there. Let's go back out. So, yeah, it eventually figured out that the intent was book flight. And it says, great, I have booked you a flight from Cairo to Seattle. And it constructed a sentence by taking the entities that it detected and then placing them back in. So that is all great here. I think it missed my breakpoints, but you can kind of understand how complicated this would get. One of the typical scenarios is what happens when you have partial information. What if they only give you the source city, but now you need the destination to actually make the reservation, and your bot has to know, do I have that yet? I should ask another question, but I should only ask for the things I don't already have. And you get into all this logic about if this entity's set, do this. If this entity's exists, then I know to do this, and yada yada. All right, so now let's stop this one. Now let's look at the next phase here. Actually, before we do that, let's go back. So this is a flowchart, I guess, or excuse me, a sequence diagram of what just happened there. The user types input, the web chat, forwards it on to the bot. Say web chat. This is going to be this emulator that I'm showing you right now. The bot just processes it and responds. Either responds with, I had it coded to say none if it detected none, or responds with great, your flights are booked. Right. So that's as simple as you can get. Now we're going to take a look at the next step up, which is, kind of offloading that language understanding to an external service. So, yeah, so let's go back here. So we're going to check out the Lewis branch. Now I've already run npm install on this to get the extra packages, but I think I'll end up publishing this. You guys can try this out. And yeah, so basically, what did we change here? We can actually look at this. If you look at the diff, I have just oops. Okay, guess I know I have to regenerate that subscription key now. No one take that one. Yeah, so what did we change here? I guess this view isn't as helpful as I thought. But I was trying to show you that we really only swapped out a few lines, and the code is very, very similar. So you remember previously I just had my own intent function that was taking in the text. Lewis, actually, you construct your own recognizer, and they call it a model. And let's go take a look at that here, because that's way zoomed in. So I had previously gone ahead and created a bot-Lewis model, and I knew I wanted to create an intent called book, because that was it was called book flight here. But anyways, so I added in a bunch of utterances for what that intent should be. I labeled them. I went through and picked all the words out, source and destination. And now I have a model that's pretty good at detecting when people want to book flights, and it's also pretty good at detecting when people are entering text that's not related to booking flights and labeling it as none. So I've got the positive and the negative case there, and I have the 2 or 3 entities. 2 of them are the simple type, which is the ones that I labeled, which is destination and source city. And this could probably be better done by hierarchical or composite entities, but I just did the basic ones. And then there's a pre-built one, which is means it's a pre-trained model that you don't get to customize, but it detects numbers, and it handles all the edge cases. Like if I type out TWO for 2 instead of the number, it gets all that, and then it resolves it to the actual numerical value for your code, and it's very nice. Okay, so let's go back to the code. So yeah, I had pre-built the model. We can just show you what it looks like. I want to create a new intent called, let's see, we'll just call it shop, just to demonstrate how the app works. So I've created a new intent, and I say, would like to buy 2 pairs of jeans and 1 t-shirt. So this is just an example of what you've done. So you can see it detected 2 as a number, and 1 t-shirt, and I might say that, I want to, I don't have a new entity at that, but you might create an entity called products and label jeans and t-shirts as product there. That's just an example of the UI. But again, I'm preemptively going and creating intents and entities so that my bot can do it, which is, we're going to see how conversational learner makes that a little bit easier. And so once that's been done, I would have gone back to my bot. I'm calling recognize. I get back the result here. I get the top intent, get the entities. I'm checking to see if it has the source and destination, and if it does, I'm going to go ahead and respond with the same thing. So we'll reset the conversation. Let's go ahead and let's see. Run. Okay, we're going to debug the Lewis bot now. Okay, so it did start. All right, so we're gonna type in something very similar. Book 2 tickets to from Cairo to Seattle. Cool. And we had written this article a long time ago and kept putting the video off specifically because they're quite difficult to get right. And here you go. You see the issues. All right. So we got 2 tickets from his Cairo to his Seattle, and we're going to send the result. Great, it's working now. Okay, so disregarding technical details, the point is that we just offloaded the intent recognition to Lewis, an external service. And now you're saying, okay, this isn't too complicated or not really pushing the limits here. You can imagine you have, 20 or 30 intents, and you've got, again, 20 or 30 entities, and you've got this user entering and leaving different contexts as they naturally flow their thought process through your bot, and you're trying to handle all this stuff. You have complexities with, you've got a really, really good model for booking flights, and you want to leave that alone. You don't want to kind of pollute it with that shopping intent or something like that. Maybe that's a separate domain, and then now you have to figure out how to alternate between these two Lewis models, and there's all this complexity around here. You can imagine as this getting more complicated, trying to scale it up. So now we've looked at a text bot and we looked at a Lewis bot. Let's jump back to the article, make sure I didn't miss anything that I wanted to say here. Okay, yeah, so a bot with Lewis was just adding the external service. And now we're going to take a look at this flowchart, which is a bot with conversation learner. And you should see it looks still not too similar, although we're not all the way to the complexity yet. User enters some input. The web chat will forward it onto the bot. The bot's going to send it to conversation learner just like it had sent it to Lewis. We actually are going to do our entity extraction. We're going to predict the next action, and we actually send the action back directly that the bot should reply with, as opposed to the bot generating the message. We still allow you that ability, we'll show that later, but it solves this extra problem that people were having. Was I have an intent and I have a bunch of entities and I have to construct a response. It would be nice if the service was kind of fully formed and knew the response, right? Now Lewis, you can't fault him, it wasn't intended to solve this issue. We're trying to solve this issue. We're a little more specific than just a language understanding. So you might have this question, if you need this note here, well, okay, that's great. How does it predict that action? Oh, that's the most important question to answer. Well, that's what we're going to look at. And so this is, the full-blown version of conversation learner during training. And this is how you train your model so that it can predict actions. So there's these 2 new loops that have been introduced into the sequence here. So we're still going to submit that input to Lewis to get entities. But we have this ability for the developer, conversation designer, whoever is operating as the trainer at this time, to look at the entities that were detected and correct them inline and then continue the bot. Now, normally, maybe you have designed this thing in Lewis, you enter some text input, it turns out you forgot to label entities correctly, and now you're like, oh, great, I got to go back to Lewis, I got to retrain, I got to republish, and then finally I can get back to coding. That's too disruptive in that feedback loop, right? You're not worried about that. It kind of distracts you from your goal, which is to get this input and output mapped into a dialogue, and that's what you care about. So that part is what it allows you to correct entity detection, and it will automatically retrain so that those entities are correctly detected the next time. And then we move on to this next part, which is called action selection. And this is, you could think of as how do we pick the action the bot should take. And again, we're using all the current information we have, which is everything that's in the current bot's memory, and then the previous actions in the conversation to predict the next one. And yeah, maybe sometimes it's wrong, but we give you a list of all of them, and you can immediately, pick the correct one. And we'll update, the weights internally, and it'll be more likely to pick the correct one the next time, right? And this, again, is a completely linear feedback loop, and we'll see this in action. So it makes more sense. And I'll also pause and point out these two areas. So let's see. Oh, of course, I have video placeholder. Okay, so now let's go to the conversation learner bot. This is the one you've been waiting for. All right, we'll kill the Lewis bot there and go to bot CL for conversation learner. So I have this pre-set up because I didn't want to worry about all that stuff during the video, but just briefly, let's go through how you would do that. So as I mentioned, we do have docs here. There's this big documentation button I highlighted, which will take you to the Azure docs, and we have a quick start guide somewhere getting started, right? So this will walk you through. Also, you can go click this link, which is SDK. It actually links to our samples repo, not the actual SDK, but here is the repo you will clone, and it again has quick start if you want to go that way. It's all similar information, and yeah, you just clone the repo, go into that new folder, you install the dependencies, you build them, which is the TypeScript compilation. You have to add your Lewis authoring key to an environment file and set this node environment. Yeah, and then you run npm start, and you should be good to go as far as the bot server. But then we have this one extra thing is we have a UI that runs with it. Now, one thing I didn't mention in the article, let me see. Okay, there was a key phrase I was looking for. Anyways, so I wanted to mention here is that, previously we were looking at the bot framework emulator, and we had Lewis and everything seemed to be working. You can imagine you could get pretty far at that. But the UI that we're going to show for conversational learner is over here. And this is, we have a service, a middleware, and UI that are purpose built for this. So you can imagine how much more tightly integrated they are and the problems they can solve that the other ones can't, because they weren't really designed in the way that these are, right? So just to make that point a little bit clear, let's go back to the PowerPoint. If you remember, this slide which shows kind of the local development setup. We have input channels, an Azure bot service on the left, the bot app, and external services. We have the bot emulator here, which was made to facilitate communicating messages to bot framework, and then you have language understanding service on the right, and language understanding middleware, which kind of goes into your message pipeline stack on your web app. And there is, one portion of the issue was solved for developers here, and another portion of was solved here. But when you go for conversational learner, we now have a link. You could imagine a kind of an arrow going across the stack here. Well, not only did this UI help you send messages to conversational learner, but it also is updating the data you have on your service on the fly as you train your model. There is a new, I think the emulator I'm showing is the V3 emulator. They have a new V4 emulator which helps you dynamically recategorize intents, which is similar to kind of what you'll see in the conversational learner UI. All right, but enough of that. Let's go to the example. So first, let's just talk about what the UI is and all the different buttons. So cognitive services, we're trying to kind of match the theme of this kind of black bar at the top that has a list of the models you've created, a link to the documentation, and a link to support. So you can kind of get a similar idea from the conversational learner thing. We have a link up here for your models. If you click this link, it will open a new page to our docs, and you can also go to our user voice for suggestions for new features. And then there's a button you'll probably never need over here called the settings page, which is for kind of advanced scenarios for ports. And of course, if you want to file an issue directly on our GitHub, you can go there and open up an issue. All right, so here we are in our UI, and we have our list of models. I've already gone ahead and created what we're going to call the book model, and let's test this one. So just quickly, now that we've selected a model, we're in the part of the UI which is reserved for that. You can kind of draw a parallel to see if let's just create a new app in Lewis here. So Lewis has intents and entities, and you obviously can add intents and then write utterances and program them and train them. We have entities again over here, and we have this thing which is kind of a new concept called actions, and this is I guess you could think of, instead of the developer having to manually, create a bot framework message response from an intent and entities, you can use some more high-level constructs to automatically do that. So we'll take a look at one of them here, where the bot is asking, what city you're departing from, and it knows that the response is most likely to be the entity called the source. So automatically do that, save it in there, and then here's another one where we allow the developer to directly type in how to construct a response from the bot using these entity values that are marked in blue here. So whatever the value for the source entity is, it will be replaced here. It also is saying that you can only select this action if the source and destination entity are available in memory, which means now you've effectively done this kind of programming that would normally be done with rules through entities, and it's just a graphical interface for that, which is really nice. But anyways, let's okay, here's train dialogues. This is probably the most important view. So these are me as a trainer demonstrating how the bot should behave. So obviously I've already built this app, but I will go create one from scratch so you can see how I've gone through this. But I just quickly wanted to give an overview of the UI real quick. So these are ones that anyone who is a contributor to the bot, like within the company or your team, you've contributed these. And for instance, I'll have an input here. I want to go from Los Angeles to Fargo. I have labeled the source city and destination city, and then I've selected the response the bot should take. Let's see, another one is kind of an out-of-domain thing where I've asked the bot to order me an Uber from my current address to the airport. It says, hey, I'm sorry, I can't help with that. Would you like to book a flight? Because remember, this model's only concerned with the book intent here, or domain. There's another one for ordering pizza. And then we have this other tab here called log dialogues. Now these, as the description says up here, are dialogues that would come from your users. And also currently in our UI, it's kind of becomes a place where you can test the bot's behavior. And this is where you've obviously done everything you can to make sure the bot's great, but your users will always find some scenario or some path that you haven't accounted for, and you just will see that dialogue come in and correct it. So let's try that now. Simulate the user and just demonstrate this kind of model I've pre-built already. So we'll give it kind of a happy path phrase, which is want to book 3 tickets from Dallas to New York. It says, okay, great. I've booked you 3 tickets from Dallas to New York. That's the correct behavior. We can try to do something a little out of domain, since I want to order a large pizza with extra pepperonis. And it'll say, I'm sorry, I can't help with that. Would you like to book a flight? Which is correct. So that's the demonstration of a working bot. Now let's look at how we actually create this, which is the more important part. And I want to bring up that article so I can take a moment to point out those spots in this sequence diagram, which are really critical to understanding how a conversational learner works. Okay, so we're going to head... briefly while I'm here, I want to say that to these buttons here, we have a bunch of tutorials that walk you through all the concepts in our app. So you can see there's intro to entities, actions, expected, negative, multi-value entities, log dialogues, session callbacks, all the different stuff that you can do in our app. We try to create tutorials for. So you can import those, and each tutorial has kind of an accompanying walkthrough on the Azure Docs. So for instance, you'll see the tutorial here called multi-value entities, and then in Azure you'll see multi-value entities here. And then also when you open up the app, there's docs that are included inside of it. Okay, so we're going to create a new model called book new. So this will be essentially a recreation of the existing app. So I've created a new model that has nothing in it, and we obviously know our goal. Sometimes you don't even know your goal, and that's kind of the point I want to make here. You just want to get started building an app, and you have some ideas about the types of conversations the users are going to have. So this is, remember the amount of knowledge you need to build the bot in this UI versus what you would need or what kind of developer access you would have. Let's see, going back here. So this is, we're going to kind of go through this flow as a user building an app, and we're going to keep looping around this until we get the good behavior for our bot. So the first thing, we're going to jump right into a train dialog. We don't need to worry about entities, actions, any of that. Obviously, if you know that, you can maybe do that ahead of time, and it will help you. Particularly, I think this is a much more natural flow. So we're just going to pretend we want to book a flight. I want to book a flight from Miami to, let's say, Seattle. Now we know that the two cities are important to us, but we haven't created any entities to hold that. So we'll go ahead and select the text. We just take our cursor, and anything that is overlapping, it will expand. Or click once and click new entity. This is going to be, I'm going to call it source for, I can call it source city if that's more appropriate. Where you can disregard these options for now. Programmatic means it's not learned in Lewis. Multi-value means it can hold obviously multi-values. And negatable is means that you can actually select a case where that value should be removed from memory, but we don't have that case for now. Go ahead and click create. Miami is now tagged, and we're going to create another one called destination city. And okay, so now this utterance from the user is correctly labeled, and we want the system, let's see, so we actually just did this entity detection loop right here. We asked the detect any entities. Obviously it detected none because our app had none. We corrected it, and now we're going to continue the conversation. Meanwhile, this is that thing I mentioned where our UI is purpose built for this. So I'm going to go ahead and click score actions. It has accepted that input, and then behind the scenes it's going to go update the model so that in the future it will detect those entities. So now we have to decide, okay, what should our bot respond with? Well, we have no actions, but we know what the user should do. So we're going to say, if you remember the old app, it's going to say, okay, I've booked a flight from, and this is our kind of This is called a text action, where all we need is to build a text string from whatever static data we have and our entities. So I'm going to use the $ to open up this little menu and pick an entity, and the value of that entity will get replaced. So it's going to say, okay, I booked a flight from source to destination. And you notice that because these entities are used in the payload, they must be available in order to construct the payload. So we add them in this bar down here called required entities. And if you're ever unsure about what these fields do, we have these little blue icons here that says more information. If you click that, it'll pop up this panel over here, which kind of explains all these concepts. This checkbox down here called wait for response. If you need multiple actions to occur back to back, then you want to be able to uncheck. You want to uncheck this box because you don't want to wait for the user. So we're going to leave it checked. It's the default behavior. Click create. So now our bot has said that, and this is our first kind of successful train dialogue. Now this was a case where the user gave us all the information we needed, but that's pretty unlikely for a user to give you kind of the perfect information. Most likely you're going to get partial information over time. You need to know which question to ask in response. So you might first only know, I want to fly somewhere. And our system in this case, we don't have an input, so we need to know where they want to fly from. So we'll say, what city are you departing from? And we're expecting the user to type the source city, but we'll see how they work with that too. So we'll say Seattle. Now, because we had told the bot that we're expecting the user to type in the source city, it automatically labeled this. And okay, now we need to know where they're landing. So what city are you arriving at? This is going to be the destination city. Now this time I'm going to give the bot something that's not as easy as just a city name. So I'll say I will land in Miami. Now, of course, it does kind of the naive thing and say, well, let's assume the whole utterance was the destination. Obviously, that's not correct. We're going to erase the default and reselect just the city of Miami. Now, one thing to note here is I'm using custom entities to detect cities. Obviously, Lewis does have some built-in geography entities that could probably detect these well-known places and label them for you. But for now, we're just going to do everything manually to keep it simple for explaining how the app works. So now I want to point out this chart we have here of the actions that are available. So the two actions below, what city you're arriving at, what city you're departing from, those are, you can see the select button is disabled because those questions only make sense to ask when we don't already know those entity values. So that's why they're stricken out and also colored in red. And then up here, these entities are green because they're filled and they're not striked out because they're required. So we have met the criteria and we can now select this action. And one little thing here, notice that it's giving you the exact thing the bot will say, but this little toggle button here allows you to see where those entity values actually fit into the thing if you're ever curious. But anyways, we'll go ahead and click select. And now our bot has successfully booked that flight. So go ahead and click done. And let's go one more train dialogue. Let's add one for, that out of demand case. So I want a burger with fries, milkshake. So obviously our bot is just for booking flights. So let's add a new action saying, sorry, I can't help with that. Would you like to book a flight? Okay, similar thing, just tag this source city and destination city, and we'll go ahead and score the actions, and you can book that flight. One extra thing we're going to do here is we're going to go ahead and add a new entity. Now this one you do have to do ahead of time. So we have this whole list. By default, they're all the entities created are custom, but we do have a list of pre-built entities that is the same pre-builds from Lewis, and we're going to use this number entity. And this number entity is great because it will normalize all the forms of English and how to say a number. So instead of just typing the number 2 for the number of tickets, maybe I type TWO, and it is able to not only recognize the number, but also translate it into the numerical value and give it to my bot so I can process that. So let's create another train dialog where the user wants more than one ticket, or at least they specify the number. So to say, I want 4 tickets from Houston to, let's see, Chicago. So it looks like it did not get 4. It might be due to a delay in training here. So let's we'll try that again. So you notice we have this training status up here on the left. It's all asynchronous, so you're submitting a request to train, and it will come back as soon as it's been processed. And let's try this one more time. Okay, so this time it correctly detected the number 2, and notice the pre-builts show up in kind of this grayed out or read-only thing. We can't edit them because we don't control these, but we can control the custom entities. So in this case, we could respond with our default action, but we actually want to ensure that we've captured the number of tickets, so we're going to create a new one. So this response actually says how many tickets they booked. And now one thing here you'll notice is now we have 2 phrases which are relatively similar, and they have overlapping criteria. So it would be a little bit ambiguous for when the bot should choose one. We can go kind of fix that and say for this particular action, we can go ahead and say don't use this action if I detected a number of tickets, because of course I will choose the other one. And so now we've kind of applied this constraint to our actions. Okay, so our bot is currently training with the latest changes I've done, and we've we've gone through this sequence a bunch of times in all these train dialogues, and we're assuming that the behavior's fairly good and our training's completed. So now we can test our bot. Now we're generating a log dialog from our UI, but you imagine after you publish and deploy your bot, a bunch of log dialogues come in for all the interactions users have with your bot. And this is how you make corrections and increase the quality of actions and quality of or accuracy of predictions over time. And maybe you find a new scenario and need a whole new, dialogue to your bot. So let's test it here. 3 tickets from, let's say, okay, so it got it right. Cool. So that's our first log dialogue. Now let's do something. Let's try to behave like we're going to simulate, a bad actor or some user who does something. So I would like to book a flight to Dallas. Okay, so in this case, I only gave it the destination city, and it correctly knew that it needed to know the source city, so it asked that question. So I guess that this means this question should not be asked here, because it should have correctly identified that Dallas was a destination city. But I see I missed a word. I said book a to instead of book a flight to, so that might be the issue. So let's go ahead and click done, because that scenario has already kind of been messed up here. So we'll correctly tag this as Dallas. And you get this warning here saying, okay, this was a log dialogue from a user. As soon as you make corrections, you're making them as a trainer and saying this is actually a good example. And so it's going to take you over here and you can continue the dialogue. And so yes, it should ask us where we depart from. I'm departing from Seattle. It correctly identified source. And then it says, okay, book the flight. And then once we've done all that, you see the row for the log dialogue disappears, and it has now been added as a train dialogue. Cool, so that's a pretty good overview of the Conversation Learner UI. All the different tabs we have here. One thing I'll briefly mention is we have this settings page. So you can change the name of your app if you like. We have these 2 buttons here. You can say you have an app that's in a pretty good state. One of the things we struggle with right now is because all your trainer logs are in a correct state. Maybe you want to take a drastic change, but you don't want to ruin all your current train dialogues. You can click this copy button here, and we're actually going to duplicate everything. And now maybe we could perform an experiment and say, okay, what if I taught my bot to behave this way? And you'll see you get all your entities, train dialogues, and stuff. So you could experiment here and then decide that concept works, and then possibly, currently you'd have to manually merge it back in, or perhaps just continue on this new bot, but that's a very helpful thing to be able to copy models and explore different ideas. We have this export button, which will go ahead and kind of save your current bot out we're having our own custom extension here, but if you save this, it's actually JSON file. We don't really want people to depend on this format. That's why we have it as /cl, because it's we are a labs project, as I mentioned at the very beginning, so there's definitely breaking changes are to be expected, and it's definitely experimental, so keep that in mind. This is just some extra information. So when you publish your bot, you're likely going to want to associate a subscription key for Lewis so that you don't use all your quota for your authoring key. So in order to help you do that, you'll go get that app in a Lewis. You actually first have to go to Azure, provision a instance of the Lewis Cognitive Service. You'll get your key, and then you go to the app in Lewis and assign that key. So it's a little bit cumbersome, but we're just pointing this button out here. We have somewhat of a tagging system going on, is to kind of take a snapshot of known good states and allow you to at least restore them. So you have this drop down here where you can create tags and deal with those. And then also here we have this option to log conversations. And again, if you don't understand what something, you click this little icon here, and it'll say this checkbox enables or disables logging of user conversations. So for some reason you have some, I don't know, like a privacy concern, you just don't feel comfortable, or your users would not allow it, then you can disable logging. And in that case, you won't get any log dialogues from your users. This will kind of limit you in a way, because you won't be able to increase your bot's behavior by correcting them, but it is at least available. Okay, so let's go back to the article. And yeah, so that was a great overview of the UI. Now, a couple things to be said. One was the challenges we have with, versioning your bot. So that's why we have the tagging there. So we'd love to get a lot more feedback on that. This bullet point is actually a little bit out of date. We have, since this article is written, fixed this, and you can now work a lot better with the existing bot framework entity or memory. They have, we have kind of one conversation of memory, but we also have our own concept of storage and session state, and you have to be careful about importing conversation data and user data into that when you start a session and also when you end the session. So there's a tutorial that explains that. And yeah, so hope that was a good overview. We have a ton of reference links at the bottom. Let me know what you think. Thanks.